All right, here we go. Second half of lesson 6.1, looking at three other properties slash rules of exponents. I did want to mention, as I was thinking about this in between videos, there is a difference between evaluate and simplifying. And when we see evaluate, I actually want you to get the numerical value. So that's why in the warm-up, when I asked you to evaluate 2 to the fifth power and you gave me 32, or we got 32, that's what I was looking for. Whereas when we're applying these rules, I don't want you to evaluate. So one thing, again, for the first example, 4 to the fifth times 4 to the third, I want you to just leave your answer as 4 to the eighth. I don't want you to multiply it out and get a really large number. The other thing I did want to mention as well is that a common mistake that students sometimes make, especially when working with bases that are actual numbers, actual numeric values, is to multiply the base as well. And that's just a common misconception here. So again, we said this was 4 to the eighth power. I want to remind you, it's not going to be 16 to the eighth. We don't multiply the bases and add the exponents. Adding the exponents is doing the multiplication. So that's one thing I wanted to remind us of. Okay, so I've mentioned negative exponents, and here we are. So we're going to get to the nose. Starting, oh, I messed this up. Okay, I'm going to fix yours. This should be the 0th exponent, and this should be negative. I just discovered this. Yours will be correct. Mine is incorrect. So let's start with 0th exponent. So any non-zero number raised to the 0th power equals 1. And so as long as my base x isn't 0, 0 to the 0th power is 1. I actually was doing some research. Some people say that 0 to the 0th actually is 1. I don't know if I actually agree with that. And there's a couple reasons why. But let's take a look at the behind the scenes reasons for what this is happening. Remember back to our rule for quotients. If I have something divided by itself, so x to the fifth divided by x to the fifth, and I use my quotient rule, which is to subtract the exponents, I get x to the 0th, right? 5 minus 5 is 0. But I also know that anytime I divide something by itself, I get 1. And, 6 divided by 6 is 1. A half divided by a half is 1. So that's why this particular rule works. It's coming from using that quotient rule, applying it where the exponents are actually the same. So looking at a couple examples, and the first two look similar, but they're different. This question, or this example, negative 9 to the 0th power is positive 1. And that's because my base is negative, but the negative number is the base, and it is raised to the 0th power. I know it's the base because it's in parentheses. That's going to be 1. This one is actually 9 to the 0th, which is 1, make it negative. So negative 9 to the 0th power is the opposite of 9 to the 0th power, which is negative 1, because 9 to the 0th is 1, and then its opposite is negative 1. Whereas negative 9 to the 0th power is positive 1. I know, it's definitely tricky. Let it sink in there for a little bit. And then again, it doesn't really matter how large our base is or how small our base is. Anything to the 0th power is 1. Now let's take a look at those negative exponents. Any non-zero number raised to the negative first power is equal to the number's reciprocal. So x to the negative first power, if we think of this as a fraction and we flip it over reciprocal, the 1 comes on the top and the x to the negative 1 go to the bottom, but this time its exponent is going to become positive. So typically we just write it as 1 over x. So x to the negative 1 is 1 over x. When we're working with negative exponents, usually what I tell myself is If I cross the fraction bar line, I change the exponent sign. So there's another way I think about this. I think about x to the negative first power, drawing a fraction bar. The coefficient here is 1, and I like to write that in. When I move my x to the negative 1, having a little moment here with my program that is allowing me to take notes. When I cross that fraction bar line, I'm going to move that x to the negative first to the bottom. I change its sign to positive. And because this moved, what I'm left with again in the numerator is the coefficient of that term, which was 1. So these examples, again, are kind of just one example, but when we work with multiple different bases and powers, and we have negative exponents, we can move things independently of each other. So negative 3 to the negative first power would be 1 over negative 3. We move the negative 3 to the first power to the denominator, change its exponent sign to positive 1, and we get negative 1/3. That's its reciprocal. V to the negative fifth is 1 over v to the fifth. Again, moving it to the bottom, changing the exponent sign. And then 5 to the negative second is 1 over 5 squared. Another way I've decided to backtrack a little bit. I started to give a different explanation, and then I decided I didn't want to go that direction, so we're going to erase that and move on. Our last property is the product of a power, of a product slash quotient. So to find the power of a product or quotient, we find the power of each number and then multiply or divide. I actually sort of like to think of this as a little bit like distributive property, in it works with our power to power rule, which is why I kind of put them underneath each other. It works with our power to power rule, but inside we actually have more than one base, okay? So in this case, we have xy is our base, and it's being raised to the 8th power. And so our typical power to power rule is to take the outside exponent and multiply it with the inside exponents. We're going to do that same thing, except for everybody as the base inside the parentheses gets that extra multiplication of the two exponents. So xy to the 8th power is x to the a, y to the a. Again, these both had 1s as exponents, and a times 1 is a. That exact same thing happens if you're dividing or have a quotient, and I just take x to the a over y to the a. So for an example, if I have 2 times 3 to the 5th power, I'm going to take 2 to the 5th power and then multiply that by 3 to the 5th power. We're going to leave our answer like that. Like I said, I don't want us to evaluate this. This would be a pretty large number. For this, the next example, f over g to the 10th. Again, I'm multiplying f to the first power and the other exponent 10. I multiply 1 and 10. And then the same thing happens in the denominator. Now, like I said, all of these powers combine with other powers. So let's say, for example, let's say this was f over g squared. So then when I use this power, I would do 10 times 2 for my g, and that would end up as g to the 20th. So that's the way all of our powers combine. All of our, rules combine. We are going to do a lot of examples in class and practice and make sure we're able to combine the rules. So there's some examples on the other side. I don't want you to actually start any of those yet. And as you can see, they can get pretty complicated. I have some challenge questions at the bottom where you can see I have multiple bases and different variables and things, and multiple rules as well. So we will tackle these example problems as well as answer any questions and make sure that we are ready to move on when we come back together next class. Thanks.